Hello everyone, I hope you guys are doing well. So today we are going to be talking about some right triangles and trigonometry. And if you don't know what that is and never heard of the term trigonometry, that's okay. We will be talking and learning more about that as we go on here. And so let's just get started here with our lesson for today. So we're going to start off with these two problems. As you guys can see, it's rectangles and we have divided them into two different sections using this line. As you can see, I divided it and it creates a right triangle. So if you guys don't recall or never have learned what a right triangle is a triangle with a right angle, which is a 90-degree angle here. So the length, leg 1 and leg 2, we call it when it comes to right triangles, and the hypotenuse. And if you never heard of that, I did record a video here, and this video specifically is going to be talking about the different legs and what hypotenuse is and so on and so forth. So if that's confusing to you, that's okay. Just the terminology will make more sense as you watch that video. But let's just keep going here, and for this problem as well. So this is just another problem, another rectangle that's just like this one, but it seems like it's a little bit bigger. And so what I want you guys to do is definitely try this on your own. So stop the video, try this problem on your own, and then go ahead and look at the solution for the video. So go ahead and try it and pause the video. Okay, I'm assuming that you did. So let's just go into our solution for this problem here. So as you can see, I started off with the two legs, which is the 4 and the 7. The 4, the first leg, and the second leg. And I can call this the first leg and the second leg. It really doesn't matter. But basically anything that is not a diagonal is what you call a leg. And this right here is called a hypotenuse. And how to spell hypotenuse is going to be also in that video, this video as well. So let's just take a look. So a squared plus b squared equals c squared is the Pythagorean theorem. And that is the formula that we can use to find either the leg or a hypotenuse. So let's take a look at this one here. So the first leg is 4. So I substitute 4 for a, and 4 squared is equal to 16, and 7 squared is equal to 49. So 16 plus 49 is equal to 65, and I have to take the square root on both sides. And finally, this x, I have to put in for substitute for c. So this is an unknown variable. I don't know what the value is. That's what we're solving for. And so when we replace the c with x becomes x squared. And then, so we don't do anything. We don't apply any operations to this x squared just yet. So we just bring it down. And then we got 65 is equal to x squared. And from this point on, some of you guys might have not learned how to do this problem right here. But let me just go over it, and then I'll tell you what you guys need to do to learn it more specifically. So in order to get rid of this square, because we want to ultimately get 1x, what I have to do is I have to square root the both sides. And when I square root a square, it actually gets rid of this square. And why? I'll show you in the video in a second. And as you can see, what's remaining is a square root of 65. So square root of 65, as you can see right here. So the more specifics on how to actually solve this problem, and this part right here, the square rooting part, is watching these videos here, okay? And I'm going to be talking about that in a second as well. So, so I want you guys to go ahead and try this problem out. And now we're going to try this problem, and we're going to go over this one. So the same deal, right? Same deal. And I want you guys to pause the video and actually try this problem out by yourselves. Okay, I'm assuming that you paused the video and you tried it out. And so let's take a look at this problem once again, starting with a squared plus b squared equals c squared. And I plug the legs in, right? The 8 goes in here, 8 squared, and 14 goes in here. 14 squared, and y goes in and substitutes for c and y squared. So 8 squared is 64, 14 squared is 196 is equal to y squared. And in order for me to get rid of the squared and just get y by itself, because we're solving for y, I have to take the square root on both sides. And this is where it gets a little bit confusing. Once again, I'll talk about how to get more understanding of this. You're going to actually factor out a 4. So 4 times 65, it's not a decimal, it's actually a multiplication sign. 4 times 65 is actually 260. And you can actually separate it by multiplication symbol right here. So square root of 4 times square root of 65 is actually just 260. So this is the same statement as that. I just divided it, or not divided it, but I just separated it using the multiplication sign here. And the square root of 4 is 2. And so my final answer is 2 square root of 65, okay, is equal to y. So as you can see, the hypotenuse for this variable y is 2 square root of 65. And the hypotenuse for the x is square root of 65. And so that's how you go ahead and do these problems here. So one thing that I do want you guys to notice is the proportions of these rectangles. So it's actually going from 4, right? 4 times 2 is 8. And 7 times 2 is 14. And so as you can see, it's just doubling in length. So because the rectangles are similar, so with the hypotenuse. So we're actually multiplying the hypotenuse by 2, and it'll become 2 square root of 65 here. Okay, and this 2 just means that it's double the size of square root of 65. So it's actually saying 2 times square root of 65, which just means that there's 2 times the length of square root of 65. So as you can see, I drew another diagram here that kind of specifies what I mean. So 4 times 2 right here is 8. 7 times 2 is 14. And square root of 65 times 2 is 2 square root of 65. So that's basically how you find the different lengths of the hypotenuse and the different legs. And now a lot of you guys were confused, okay? Mr. Kim, it sounds all good here, but I'm really confused about what the Pythagorean theorem actually is, and I'm pretty confused about the square rooting stuff that you did right here. So the Pythagorean theorem, I don't know what that is, and the whole square root thing, I just didn't understand. So if that is the case and you're having a trouble with that, then I do encourage you guys to watch these 3 videos. So this video specifically talks about what the square root actually is. Like when you look at this like symbol, the square root symbol here, like most of you guys probably don't really know what square rooting actually is. Square rooting is the opposite of squaring something. And so maybe if I can just show a part of the video. And when we're talking about square roots, we're actually literally talking about squares. And so that's actually a very important concept for you guys to realize and know where and why the square root exists. So let's see if I can just scoot it, find a good part of the video here. So maybe like here seems pretty good. Okay.
If we take the square root of 64.
So as you can see, so this 4, I do encourage you guys to watch the entire video. I'm just showing you like the basics of it, like the main point of it. So after I talk about it, I do encourage you guys to stop the video and watch this video because it's really, really important and it will help you a lot. So if you guys take a look, it's literally talking about a square, right? So if you talk about 4 squared, right, there'll be a little 2 here. I think if we keep going, maybe.
Our result is
show
8.
You, okay, right there.
Our bold.
Okay. If you take a look, 4 squared is literally talking about a square with the length of 4. That is what literally that is talking about. And the square root.
Whole numbers.
So I think the square root right? The square root is basically finding the length of the side of a square, which the area is 16. Once again, the square root is giving you the length of a square in which the area is 16. So square root of 16, as you can see,
our result is 4.
4. Why? Because that is the length of that square. So it's very, very important for you guys to realize that square root, it's just finding the length of the square, and then that square, as you can see right here, is literally referring to a square that's 8 long. The length is 8 and the width is 8. So this square is literally talking about a square. So that's really important for you to know, and I think it's kind of cool to know that this square isn't just the symbol that we use, but it has real mathematical implications and meaning behind it, which is literally a square. So I do encourage you guys to watch this video here, because this will explain, the reasoning behind the square root and the squaring. And so if you want to go ahead and pause the video and watch this video right now. Okay, I'm assuming that you watched this video. This video is going to talk about basically just how to solve questions like x squared is equal to 64. I do encourage you guys to watch the video up to 2 minutes and 11 seconds. You guys don't have to watch the entire thing, because as it goes on, it gets a little bit confusing. It talks about parts that we haven't learned yet. So maybe I can talk a little bit about here what he talks about.
Multiply to give us 64. Well, the answer
he
for that
basically goes and solves it, right? As you can see, this x squared equals to 64 is literally like here, right? Instead of 64 is 65. And so he talks about here how to solve these types of problems in this video, okay? And so if it goes here, it gets a little confusing. So he talks about x plus b, x plus c, x squared plus b, x plus c. So don't worry about that. Don't go beyond to 11 here.
Product, x.
Okay, to 11. So I encourage you guys to pause the video right now and watch this video and take some notes on it. You don't have to take notes on this one, because this is just for you guys just to kind of get an understanding, but I do encourage you guys to take notes on this part here. Okay, so I'm assuming that you paused the video and watched this one already, and then now let's go to this one. So this one is simplifying square roots, and so as you can see, we got square root of 24, and this number 3 video is going to help you with this one here, right? So we have to simplify the square root, because it can be simplified into a simpler form, which is 2 square root of 65. So this video is going to be helpful for that. And so I'm going to play a little bit, see if I can find the spot that's good for us to talk about. Here we go.
4 times 6.
So as you can see, he's simplifying the square root of 24 with 4 times 6, right? And so he's basically going to go ahead and talk about how to solve problems like this and how to simplify square roots that can be simplified, such as this one here. And so I also provided some practice. So after watching this video, you're still confused. You're like, oh, I'm still shaky. I want some more practice. And then you guys can take a look at these 2 practices, click on them, and then you guys can practice it to get more mastery over those skill sets. So I really do encourage you guys. It's just Khan Academies, and I think it will be very helpful. So I do encourage you guys to click on that and do some practice. And I know it's like a lot, and but yeah, it's all these skills are really necessary for you guys to be able to just solve for the lengths of the leg or the hypotenuse of the right triangle. And so after you guys go over this, the Pythagorean Theorem. So these 2 videos, just like this one video, the first video that we watched for the square roots, is to explain the reasoning behind the Pythagorean theorem. Why does it exist? How does it work, right? And so I'm going to just quickly play this video and talk about the main point. So as you can see, this figure, the area of this square and this area of this square added together will actually equal to the area of this square. So we'll take a look at this, and then voila. See? Voila. Whoops. No, it's not that one. That one right there. See? As you can see, all this water fell into this into this spot, and this area, and plus this water, so the water in this tank plus the water in this tank is equal to the water in this tank. As you can see, it's a square, right? It's a square. And this is another square, which is literally what we've been talking about here with the square roots and the squaring. And that's where the Pythagorean theorem comes from. This square plus this square is equal to this square. Look, this square plus this square is equal to this square, right? This squared is literally referring to a square, as we talked about in this first video. So that's what this video is gonna be about. I do encourage you guys to pause the video right now and take a look at it for yourselves. It's a pretty cool video. And so this is more of like a visual without numbers. This one is a visual with numbers. As you can see, I'm gonna just skip to the end here. So as you can see, if you look over here, this area is equal to 9, right? So look, you count it, it's 9. So the area of the square is 9. There are 9 little squares here. And here there's 16 little squares. 4 squared, right, is 16, because 4 times 4 is 16. And we got 5 squared, which is 25, as you can see. Look, 9 plus 16 is equal to 25. It's pretty crazy, huh? So the Pythagorean theorem is literally this square plus this squared is equaling to the square of the hypotenuse. And this length right here, the longest length of a right triangle, is what's called the hypotenuse. So that's how that's all related. Once again, a squared plus b squared is equal to c squared, which is literally the equation that we've been talking about here. And so these two videos will show you where and why the Pythagorean works and where it comes from. And this right here basically teaches you how to use the Pythagorean theorem. And I'm not going to go into too much detail about this. You guys don't have to take notes on these two, but I do encourage you guys to take some notes on this one, because it will be really helpful for you guys to learn about it through here, okay? So here, so it gives you the problem, right? 3 squared plus 4 squared, what is the length of C or the hypotenuse, and then it will show you how to do that as well. So that's basically all the videos for this one. I do encourage you guys to pause the video now and watch this video and take notes on this video, because you guys need to know how to do that in order for you guys to solve the rest of the problems. So now let's go into our number 1, right? It says draw a square with a side length of 1 unit. Estimate the length of the diagonal, then calculate the length of the diagonal. So I want you guys to pause the video right now, and I want you guys to try this problem on your own. So draw a square with the side length of 1 and estimate the length of the diagonal. Okay, so I'm going to show you guys how I did that. So you guys see a square, and then the length of 1 on each side. I drew a diagonal line, and I got 1 here, and then I got the C for the hypotenuse. And then I basically substitute these legs, right, into the Pythagorean theorem, which is a squared plus b squared equals c squared. And so I put the 1 and 1 right there. 1 squared plus 1 squared. 1 squared is 1. 1 squared is 1 is equal to c squared. Take the square root of both sides, and c is the square root of 2. So c right here, the value is square root of 2. So that's really important. One of the things that you'll continue to recognize is that one thing that I should talk about here is that this right here is a right triangle, which means that that is a 90-degree angle, which means if I cut it in half, this right here is going to be 45 degrees, and that's going to also be 45 degrees, because 45 degrees plus 45 degrees, which is 90, will make the 90-degree angle. And so the reason why this is special is because now we're going to be talking about a special triangle called a 45, 45, 90, 90 triangle. And that is a very special triangle that you will see over and over again in your math careers. And that's what we're discovering right now. So 45, 45, 90 special right triangle is what it's called. All right, so now let's go ahead and do this problem. I want you guys to actually draw these out right now, and pause the video, and I want you guys to compute the ratio of side to diagonal length for each. So which means just find the value for the diagonal for each of the squares. Okay, pause the video and go ahead and do that. All right, I'm assuming that you did. Okay, so let's take a look. So I got a squared plus b squared is equal c squared. Once again, I just plug in the 2 for the lengths. Boom, boom. And it becomes 2 squared, 4. 4 plus 4 is 8. A square root of 8. In order to get rid of the square on the diagonal variable, I square root on both sides. And then I can factor out the 4. Square root of 4 is just 2. And then I got 2 square root of 2 is equal to d. So the diagonal length right here is 2 square root of 2. So is this one. As you guys can see, plug in the 3 for the legs, simplify, add, simplify, square root, and then factor out the 9, and 9 times 2 is 18, right? And then square root of 9 is 3 square root of 2, which is equal to d right here. And then so on and so forth, blah, blah, blah. And then you'll find that it is 4 square root of 2. If you want to pause the video and just really look at the work for it, then you can do that right now. And then we got 4 square root of 2. And then finally, so as you can see, and then let me just talk about this one. The lengths of the legs are x. And so this one's a little bit confusing, so I'm going to take it a little bit slow. Substitute the a for x, substitute the b for x. So you got x squared plus x squared. X squared plus x squared is 2x squared. To get rid of the square here, square root to both sides. And then I got square root of 2x squared. So, and then I can split the two values here with the multiplication, and square root of x squared, it's just x, and then square root of 2 is just square root of 2, and that is the length of the diagonal. So why is that important for me to discuss? The reason why it's so important is because now we find a pattern. And this is the pattern that I want you guys to see. I want you guys to pause the video, and I want you guys to actually try to find the pattern for yourself. Okay, I'm assuming that you tried to find the pattern of what that is. The pattern actually is, look, you see the length of the diagonal is the length of the leg times square root of 2. Right? That's the pattern. The length of the diagonal is the length of the leg times square root of 2. The length of the diagonal is the length of the leg times square root of 2, 4 square root of 2. So that is actually, so as you can see, this is the conjecture, or this is the rule that we can find with 45, 45, 90 triangles. So once again, this is a 45-degree angle. That's a 45-degree angle. Why? Because this right here is a 90-degree angle, right? And the 90-degree angle divided into 2 is 45 degrees. And then this right here is also 90 degrees. So that's a 45, 45, 90 triangle. So if this is 10, if the leg is 10, it'd be 10 square root of 2. If it's 15, it will be 15 square root of 2. If it's 31.5, if the leg is 31.5, the diagonal is going to be 31.5 square root of 2. So that's basically the conjecture. So I want you guys to pause the video, and I want you guys to write this down, because this is immensely important. It is a rule, it is a truth of mathematics that anytime that you see a 45, 45, 90 triangle, we learn is that the hypotenuse is square root of 2 times the length of the base or the height of the triangle. If you guys don't like the base or the height, you can say the length of the legs of the right triangle. So length of the legs, you could also say legs of the triangle. Or, okay? So that's basically a conjecture and a truth that I think everybody should know. And so make sure you draw this and copy this down because it's hugely, hugely important. All right, so now let's go ahead and do these problems. Now, we want to calculate all of these lengths, and this time around, I don't want you guys to necessarily use the Pythagorean theorem, but I want you guys to use the conjecture right here that we learned in order to solve these problems. Okay, so once again, I don't want you guys to try to use the Pythagorean theorem to solve for the lengths, the missing sides of the triangle. I want you guys to try to use the conjecture that we learned here to solve it. Okay, so pause the video and try to do that. All right, so I'm assuming that you guys did that. So let's take a look here. So if you guys see, the length of a triangle is 3, right? So this length is 3. And so the answer to, if the length is 3, the length of the leg is 3, then the hypotenuse has to be the length of the leg times square root of 2, right? Because this side, remember, is x square root of 2. So remember, this side is x square root of 2. If this is x square root of 2, whatever the number is in front of the square root of 2, which is the x, will be the length of the leg. So if this is 3 square root of 2, right, this x, the 3 would represent x. So would this 3 would represent x, right? So that is how you find the length of this one. So you guys don't have to use the Pythagorean theorem every time for the 45, 45, 90 triangle, because you can just use this one here. Okay, you can use the conjecture. So same thing with this one. Okay, so we know that, so this value wasn't given, right? So we got that 14. If this is 14, then this is also 14. Why? Why? Because this, remember, was a square, right? I'm going to draw it real quickly. It's going to be kind of messy. Remember, it used to be a square. A square is all of these lengths are all the same. All the sides of the square are the same. Therefore, if this is 14, this length also must be 14. I think I pressed undo one more time. Okay. So this length must be 14. And if this is 14, if one of the legs is 14, then for the hypotenuse, what we have to do is we just have to smack on a square root of 2 at the end of it. And then we have the length of the diagonal, which is 14 square root of 2. Okay, so basically this is a conjecture. Now this is where it gets a little bit more confusing. Okay, well before that, this is also equal to x, and this is equal to x, just as you guys see right here. For the previous problem, right, you see this problem right here, the x basically represents 14. So that would be 14, 14, and then we got 14 square root of 2, right? So that's how that works. And then now finally we have this problem here. So if you guys can see, this length represents 12 square root of 2. This length represents 12 square root of 2. But how did I get that? Now this gets a little bit confusing here. So yeah, buckle up here. So we know that this length right here is the hypotenuse. And the hypotenuse is equal to x squared of 2. So if you take a look, the hypotenuse is equal to what? X square root of 2. You see this x squared of 2? So the hypotenuse, 24, is equal to x squared of 2. And now we have to solve for x. Because when we're solving for x, now we can find the length of the leg. So if we solve for the x, we can just find the length of the leg, because the length of the leg is just x, okay? So what we're going to do is we're going to solve for this here. 24 is equal to x squared of 2 is literally right here. I'm going to divide square root of 2 on both sides so that I can get the x by itself. Now, one of the rules that you will learn about math is that we do not want to have a radical on the denominator of the fraction. And so there's something called rationalizing that we do. And so we actually multiply square root of 2 over square root of 2, which is, by the way, this is just equal to 1, because anything divided by the same thing, 4 divided by 4 is just 1, 5 divided by 5 is just 1. So it literally, actually, and 1 times 24 over square root of 2, it's just 24 square root of 2. So we're just multiplying 1 here. So if you multiply that out, we'll get 24 square root of 2, and then 2 square root of 2, 2 times square root of 2, 2 square root of 2 times square root of 2 is 4, square root of 4, and square root of 4 is just 2. Now, if that doesn't make sense, I want you guys to watch this video. And this video will help you explain how to get rid of the radical that is under the denominator, okay? So go ahead and pause the video, and I want you guys to watch this video, and it will help you how to solve this type of problem. So you're like, okay, Mr. Kim, I don't believe you. I don't know if this is actually true or not. So let's take a look. So as you can see, the x value is 12 square root of 2, right? So we found the x value. The x value, 12, what does that say? Yeah, 12 square root of 2. So it'll be 12 square root of 2, and this right here was 24. Yeah, it was 24. So let's actually plug it in and test it with the Pythagorean theorem right here. So you see the 12 square root of 2, 12 square root of 2, 12 square root of 2, 12 square root of 2. Those are the two legs. And the x squared, 24, right? 24 squared. So 12 squared is 144. Square root of 2 squared is just 2. 12 squared is 144. Square root of 2 squared is just 2. This is kind of like the distributive property using a square. And then 144 times 2 is 288. 144 times 2 is 288. And 288 plus 288 is 576. And 24 squared is actually 576. You can put it into calculator to check. And as you can see, it is in fact these two lengths does equal to that hypotenuse. So this is true, which means that I did the math correctly here. That if the length is 24 for the hypotenuse of a 45, 45, 90 triangle, so will the leg be. The leg will then be the 12 square root of 2. Okay, so I just did 2 more problems here because I think it's a little bit confusing and it can be a bit difficult for you guys to try to do these problems on your own. And so, so let's take a look at this one. I want you guys to pause the video. Just imagine that this right here isn't there. And I want you guys to just draw this out, pause the video, and solve for the different legs of the right triangle. Okay, so I'm assuming that you tried to solve for this and how you got to, and let's now talk about how we got 6 square root of 2. So as you can see, this side right here represents x squared of 2. Remember, going back to the conjecture, the hypotenuse represents x squared of 2. So the hypotenuse 12 is x squared root of 2, x squared root of 2. Divide the square root of 2 on both sides, voila, voila. And then we got 12 square root of 2 is the answer. And then we rationalize by multiplying square root of 2 over square root of 2 on both sides, or for the numerator and denominator. And then we got 2 square root of 2, which is 4, square root of 4. And 12 times square root of 2 is 12 square root of 2. And then square root of 4 is just 2. And then 12 divided by 2 is 6 square root of 2. And so that's how we got the length of the 45, 45, 90 triangle with the hypotenuse length of 12. Why? Because the x is 6 square root of 2, right? X is 6 square root of 2. And as you can see, x right here represents the length of each of the triangle, of the legs of the triangle, of the right triangle. Okay, so that's that. I want you guys to pause the video and try this problem out here on how to solve for the legs of a 45, 45, 90 triangle. Okay, so I'm assuming that you paused the video and tried it out. So let's talk about this. So this length hypotenuse represents x squared root of 2, right? X squared root of 2, as you can see right here. And once again, I find this in the conjecture, x squared root of 2. And so let's go here. Once again, I divided the square root on both sides, and then 16 over square root of 2, multiply square root of 2 over square root of 2 for the numerator and denominator, and then square root of 2 times square root of 2 is square root of 4, and then 16 times square root of 2 is 16 square root of 2, and then square root of 4 is just 2, 16 divided by 2 is 8, and we got 8 square root of 2 is the answer for the leg. So this is the 8 square root of 2, and this would be 8 square root of 2. And the reason why I didn't write that is because I didn't want you guys to see the answer right away. So that is that. And then finally, I want you guys to watch this video. This is just kind of the overview of everything that I talked about, the importance and the conjecture, the rule that we derived using the 45, 45, 90 triangle. And I think it's a good overall review video for you to watch for the closure of this lesson. So I hope that helped, and that concludes our lesson on the 45, 45, 90 triangle lesson. And that's it. All right, I hope you guys have a great day, and I'll see you guys in the next video. Okay, bye-bye.